Okay, this is section 2.1, question P7, and we have a relative frequency histogram here of life expectancy in 223 countries around the world. So the first thing I want to do before I even jump to the questions is get a handle on what is going on here. So here I have a relative frequency, so I know, similar to the last video on P6, that this is the proportion of the total population that the data falls in. For example, if I look at this bar right here, it's coming across at about 0.7. So about 0.7 or 0.07, sorry, 7% of my total population has life expectancy between 50 and 55. In other words, of the 223 countries in the world, about 7% of them, the average age that people live to is between 50 and 55. Now, one of the first things I'm curious about when I look at this is this section of the data right here. What does that actually mean? Well, whatever this country or countries is representing here, their average age is only between 30 and 35. That's drastic. I mean, I would, on average, be dead by now if I were living in this country. I'm kind of curious what country that is. So I'm going to go to Google here. And is this something that you have to do for the question? No, but I think it's good to, so I'm seeing life expectancy by country. I think it's good to get a sense of what the data actually means, to take ownership of it, make it more exciting. Since you are investing a lot of time and energy in this course, I would recommend that you take advantage of it and actually get something out of it that's connected to your life. So I just Googled list of countries by life expectancy, get this beautiful chart here that's actually similar to the Hans Rosling video you'll be watching next week. And I can see by the chart right here that this is male life expectancy, female life expectancy. Angola appears to be the country that was hovering down there at the lowest mark. And I'm sure they'll have a list here, which they do. So Japan has the overall highest life expectancy. So assuming that you can avoid any nuclear fallout there, if you do want to extend your years on Earth, maybe consider a move to Japan or Andorra, which you may not be as familiar with. Singapore, a beautiful country. I've been there a couple times. And you may be curious where the US falls in terms of life expectancy. So we have this image of US as having a pretty high standard of living, but did we pass it? So what I'm going to do here is quick search for United States. Okay, I did pass it. Okay, so it isn't too bad. 36, so we're a little bit below 80 here, which I'm guessing this is the female and this is the male. But it is about 5 years less than the average Japanese life, and I would assume that's in part because of diet differences. So let's spin all the way down here to the bottom. And notice this list only has 193, so our Wiley exercise was counting more countries for one reason or another. But Sierra Leone here is falling as the lowest. So we also notice that this doesn't quite match the graph up here, because here Angola was the lowest. And here we have Sierra Leone, both countries in Africa. And here's a list from the United Nations that has Central African Republic, Lesotho, and another list. Okay, this is alphabetical, so we're not getting in order by. One nice thing to know, if you click on any of these categories in Wikipedia or in many charts, it will sort by that total. So here we see that Haiti has an average lifespan of only 32. So that is actually the first non-African country we've seen at the bottom of the list. Interestingly, we see that in Haiti, the female life expectancy is over 10 years longer than the male. So it may be interesting to figure out what's going on here. So these are all questions that are running through my mind as I look at this, and as you get annoyed at me for diverging from the intended exercise here. But I do think it is fascinating to investigate what this is actually saying, because they are using authentic data in these exercises, so take advantage of that. Okay, so estimating the proportion of countries with life expectancy less than 45. So in other words, we want to count these people, and these people, and these three groups of countries. Well, here it looks like we're getting about 5% of the countries. Here, maybe we have a total of 1%, which would give us 6% total of the countries falling 45 years or younger. So if I put 6% in there, that would have been correct. It's giving us a tolerance of 2%, so between 5 and 9 would have been an acceptable answer. Then we have estimate the nearest integer, the number, so not the proportion, but the number of countries with a life expectancy of less than 45 years. So how would we do this? Well, so keeping in mind that I got an answer of 6% here, what would I do with that 6%? Well, here I'm going back to notice that this data is representing 223 countries. So if I take 6% of that, let's grab this calculator here, 6% of 223, I would get 0.06 times, I guess I could have used my times button on the computer, which I didn't, and I'd get 13.38. Now, because we're talking about countries, a fraction of a country isn't very helpful, so I would probably round that to the nearest integer of 13. And notice again, the tolerance is 5 here, so between 11 and 21 would have been acceptable. And that's the absolute number of countries rather than the percent of countries with this short life expectancy. And it's really sad, by the way. This is something that I think statistics can be used to help measure and hopefully raise those life expectancies through awareness of what's going on around the world. And we will take a look at that later in the course if you're interested. So now we want the shape, center, and spread of the distribution. So any distribution is going to have these characteristics that are important. The shape of the distribution is skewed. In other words, we don't have that typical bell. We have the data kind of collected over here on the right. And this is something that I've never been real happy about how the name was chosen. But when we're talking about skew, we're talking about where is the longer tail. And so we can see that it's to the left here. So we would say that this data set is skewed left. This distribution is skewed left towards the smaller values. These are the smaller life expectancy. The median, so median is where we're going to get 50% of the data below, 50% above. How would I get that? Well, I noticed that if I start from the right, I'm going to get to the median a lot quicker than if I start from the left. So I'm going to start from the right. I'm going to follow this over. Let's say this is a little below 10%. Here I'm going to get about 30%, so that's 38% so far. So I'm going to hit my median somewhere in here, right? That 50% mark is going to be somewhere between 70 and 75, maybe 72, 73. And I'm going to select this as my option. The middle 50% of the life expectancies. In other words, if I chop off the bottom 25% and the top 25%, what does that leave me with? Well, let's find out. So we already said that this was about 6 or 7 to get us up to this cutoff. We're going to throw another 5% in there, so that's about 11%. Here we're getting about 7, maybe 18%. Here's another 4, 24%. So the 25% mark is right around 60. Going backwards from the other direction, here we have our 8, and right away we get into that top 25% cutoff, somewhere here So I'm going to say somewhere between 60 and 80. Now I know the choices aren't going to necessarily reflect that, so I'm going to choose the closest option that they give me, which is between 60 and 75 years. In other words, the central portion of the data is here. Most countries, in general, most countries have an average lifespan between 60 and 75. Then we have some of these really good places to live, of which United States is one in terms of life expectancy, and some of these where we really have some shocking things going on in terms of early premature deaths.